Hey, what's up, guys? This is Guy here with KBTrainings. So the lesson you're about to watch is one of the lessons that I'm creating on KBTrainings.com for the course on the Cisco CCNA 200-301. So if you are an IT professional or if you are trying to become an IT professional, the CCNA is one of the best certificates out there that you can do to get in the field or just to boost your career and get to a better position, better paid and everything. So the CCNA is available on KBTrainings.com. So if you want to see all the curriculum from the introduction to networking, I actually go from zero to engineer, and everything is there to help you with a very well done courses or lessons, 4K videos that you can watch at your convenience. And I put a lot of time into it. I put a lot of patience so I can explain everything in detail, do a lot of research, and of course include my own experience to help you understand all the concepts and get your CCNA certification. Or if you just want to know networking and you just want to have all the basic notions that you need to be well in your career, whatever you're doing right now, the lessons are available. So thank you guys and enjoy the lesson. Hey, what's up, guys? This is Guy here with KBTrainings. Today we're going to see the lesson number 5.3.2, in which we're going to talk about service providers. This is for our lesson on the Cisco CCNA 200-301. We are on the chapter 5.3 talking about WAN architecture. In the last lesson, I talked about the introduction to WAN architecture, and I told you that WAN networks are owned or operated by service providers. I mentioned some of the services that you can get with a WAN network. So those services are provided by a service provider. So today we're going to cover these different points here. First of all, I'm going to tell you what is a service provider, and we'll give you the different tiers of service providers that exist. In general, you're going to see 3 different tiers. We're going to talk about them. And I'm also going to give you a service provider architecture, a typical service provider architecture that you're going to find in the industry. So what is a service provider? A service provider is just a company that does WAN. So they own, they operate, they maintain a WAN network, a wide area network, for many reasons. They do that to sell services to other service providers, or they also sell services to businesses or to residential customers. So they are called service provider. They provide many services, including the internet. As I said last time, the internet is one of the services that are provided by service provider. It's not the only one, it's not the main one, but it's one of the services. And if a service provider is providing internet, it's called ISP, Internet Service Provider. Most of the service providers are ISPs, but not all of them provide internet. Some of them may provide just like core access in a certain region, but they don't provide internet per se, but they can help ISPs move their internet traffic inside their network. And we also need to know that every service provider has an autonomous system number. It might have multiple autonomous system numbers, and that usually comes with acquisitions and mergers. So when you acquire another company, their autonomous system number becomes part of your autonomous system numbers. So it's very common to see a service provider with tens of autonomous system numbers. So that's in general what a service provider is, and I'm going to give you a general overview of what the architecture looks like. Let's do that here. I'm going to design that. So usually a service provider is represented by a cloud. You usually have a cloud, but as engineers, we know that this is not only a cloud. This is more than a cloud. In a cloud, we are hiding multiple devices. So we have multiple switches and routers inside the service provider. And I'm doing this just to show you the different names that are given to these different devices. And here we have a small cloud that is for the customer. So the cloud in this instance is for the customer, and the customer has multiple devices inside their infrastructure. And we have a different another small cloud here for another customer. It might be the same customer. Let's say it's the same customer 1 that is in Denver and at the same time in LA, for example. So how do you call these different devices? The device that is at the edge of the network of the customer is called customer edge device. This is called the CE, or customer edge. The device that is at the edge of the provider is called a PE, or a provider edge. And usually when you are connecting to a service provider, you are connecting your CE to the PE. So you're connecting your device to the to the provider's device. The CE might be provided by the provider. It might be owned or leased from the provider. So this is a CE, that's a PE. So all of these are PE because they are edge devices. PE, PE, PE. I also need to show you the different connections. So the PEs are connected to core devices. And the core devices are called P routers because these are inside the service provider. And the P routers are usually highly interconnected among them. So a P router is a provider router that is inside the provider's core. This is the core. And the core is the core of the provider's network. It goes from city to city. It might go from country to country or continent to continent. These are high capacity routers. We're going to talk about this, but I just want to give you this overview of how everything is laid out. And then we have the CE here that is connected to the PE, and we have the C. The C is just means the customer's device. This is inside the customer's network. It's not seen from the outside, but it's inside and connected to the CE. So now let's talk about different tiers of service providers. You need to know that service providers differ by their sizes and the services they provide. So we have different tiers. These are not set in stone. Sometimes you can see a scale of 1 to 5, but usually what you find is a scale of 1 to 3 in terms of service providers. So a tier 1 service provider is a global service provider. This one is a global network that has a large presence and a large infrastructure across the world or across a country. So this is very huge, and usually they connect to other tier 1 service providers for peering. Peering is that process where, or the concept where these tier 1 service providers, it might also happen at tier 2 or tier 3, but here we're talking about tier 1. So a tier 1 service provider can connect to another tier 1 service provider to exchange traffic for free. It's usually called settlement free peering, where this tier 1 has a lot of customers, the other tier 1 has also a lot of customers, and they want those customers to be able to interconnect. They're going to exchange traffic, exchange routes. So these are big networks. They usually have a core or a backbone, a big core or a big backbone across a country or across the world, and they're using that to sell access or transit to smaller service providers or smaller internet service providers, and even to business customers of different types. So for tier 1 service providers, I give some example here of AT&T, for example, which is a huge American service provider. They have a huge core across America. They actually are one of the first service providers in the industry because they were the one that laid down those telephone cables a long time ago. It's about maybe in the 1930s. They started creating that huge network that they are using today. So they're one of the main players in the industry. We also have Lumen, which is a company that I worked for. I have always been working for service providers. I've worked for Lumen. Back then, I worked for Level 3, which was later acquired by Lumen. But Lumen is a large service provider across the world. They have a huge footprint across different countries, and they acquired large companies in the past, like Level 3 or Global Crossing or TW, all kind of service providers are under this. That's why you're going to find a lot of autonomous system numbers just for this single service provider. There's Comcast that I worked for in the past as well, GTT, Deutsche Telekom, Orange, if you want to call it in French, Orange, which is big in France, Deutsche Telekom in Germany, and so on. So these are tier 1 service providers. We also have tier 2 service providers. These are usually regional. They are usually in a certain region, and they're sometimes limited to that region, or they might be in 2 or 3 different regions at the same time. They peer with other network, but also purchase IP transit, which means that they can peer with a different network or a different service provider with which they are at the same level. They can peer for free. Or if they want to peer with a bigger service provider, they're going to buy transit. They're going to allow their traffic to go through that bigger service provider to reach another service provider outside, or to reach a customer inside that tier 1 service provider. So some tier 1 service providers are just nice enough to let them connect with them for free. Some other ones will give you some conditions where you need to pay something for your traffic to go through your network, or to go inside their own network. I'm going to talk about the internet in the next lesson. I'm going to give you all the different concepts and notions that you have to know related to the internet and how it works. Things like point of presence, or IXP, or internet exchange points, or all those things. I'm going to talk about them in the next lesson. And you also have tier 3 providers. These are called access service providers because they're usually taking care of the last mile. They're usually local. Some of them are small, some are not so small. And I'm going to show you this example here. This is showing you the different way the global, the regional, and the access can interconnect. Here we're talking about ISP, or internet service providers. You can see that we have a global network here, or different global networks that are connected between them with these settlement-free peering that we talked about, or with any kind of interconnections for the benefit of their customers. And we also have the regional ISPs that are connected among them as well, and they are also connected to the IXP, which is like a colocation or a point where they connect with many other networks. This is a smaller access ISP that is connected to the IXP, and that's how it's integrated. And as I said, a single company can have a global presence, a regional presence, and a local presence as well. Many of those companies are, but they cannot be present everywhere. They can have a global presence somewhere, and if they want to reach a certain customer that is in a different area where they do not have local presence, they're going to cooperate, or they're going to talk to other service providers to be able to get that access. I'm going to get into it sometime later in this lesson. So if you like these kind of videos, make sure that you like it on YouTube and subscribe to the channel if you haven't, to have all kind of good videos like this, where I talk about everything that I learned, everything that I'm doing in the background in terms of IT. Follow me on Facebook, Instagram, and Twitter. Thank you, and enjoy the lesson. Now I'm going to give you what is a typical service provider architecture that you're going to find. And I say typical because some designs can deviate from this typical architecture that I'm going to give you, but you're going to find the main component of this, because this is what is recommended in the industry if you want your network to be resilient, to be redundant, and to have all kind of benefits. You need to kind of follow a certain way of designing. That's why most of the companies, most of the vendors like Cisco, Juniper, they usually have acceptable designs. Like they have designs that they are recommending to customers to implement in order to keep their network clean and free of any kind of mess. First, we're going to start with this here. This is showing you the different layers that we're going to talk about. It's giving you the overview of what each layer does and how they are interconnected. Let's start from this side here. This is the access layer. So this layer is the layer that goes directly and connect to the customers. And we have many kind of customers. We have residential customers, we have business customers, we have mobile customers. And by mobile, I mean the wireless connections. It might be 4G, 5G, and so on. So this is included at the access level. And the access also includes all the switches that are being put in place to be able to connect directly to those customers, either for Ethernet services or for more than that. So these switches are deployed across a city or across a certain region. We also have termination devices for things like DSL modem. This is a DSL modem that is connected to a DSLAM. We're going to talk about DSL in one of the next lessons. And we also have things like CMTSs that terminate the cable modems and everything. So that will come in the access layer. This is where we get access to the customer. And then the access connect to the aggregation layer. This is the layer that is aggregating all the flux of traffic that is coming from different types of customers or different services that we offer to the customer. It's being aggregated in the aggregation layer. And this is where we find PE devices. I talked about PE, or provider edge. they are found here, because if we look at this at the layer 3 level, we can see that we have a layer 3 device that is probably somewhere behind this modem here, and it's going to be connected to a layer 3 device at the provider's level. So that's why this is the PE, and this one becomes the CE, or the customer edge, in terms of layer 3. So beyond the aggregation layer, we also have the edge layer. This is the layer where we're going to find most of the services, or most of the modules that constitutes the service provider. By modules, I mean like the peering module, for example. This is where we find devices that are going to peer with other networks. This is where we're going to find devices that are going to terminate, like the BNG or the broadband network gateway. It will end up here. Like we have some kind of DSLAM or anything, it's going to come and connect here. We also find ISP data centers, where ISP need to host some of the main services like DNS, DHCP, and all kind of services that they need, or even CDN. They are here in a data center. So those are at the edge level, like enterprise layer 3 VPN for business customers and so on. This is at the edge, and then after it goes in the core, and the core is what puts everything together. The core goes across different countries. The core is very redundant. The core has high capacity routers that are able to transport IP and MPLS traffic as well. Okay, this is an overview of the different layers, and I'm going to show you another image here that pretty much says the same thing, or shows the same thing. And again, these different layers, this is best practice. This is what should happen. But as I said, sometimes you can find a network that merges the aggregation and the edge and just call it the edge, or just call it the aggregation. But the main idea behind it is the same, just to separate your network in different segments or different layers, so you can avoid having a mess or everything just put together. And in this example, we can have here the access layer, where we find Ethernet, we find switches, we find DSL connection, we find PAN devices, we find 2G, and this is an old image. We find 3G, 4G, 5G, LTE, all kind of wireless connectivity. This is at the access layer, and we have customers on this side. This is the CE, or the customer edge, and we have residential customers, we have mobile subscribers. And then it goes to the aggregation layer, where everything is aggregated together and sent to the edge layer for different kind of business services. As I said, a layer 3 VPN, layer 2 VPN, or we have the broadband network gateway. We also have things like RNC, or radio network controller. This will control the different radio towers that we have at the access layer, and so on. And after that, of course, it goes into the core where everything is interconnected. It's usually a full or a partial mesh inside the core, but at least you need to make sure that the device has a lot of redundancy. Like all the links have a lot of redundancies. So this one can go down, this other one can go down. This device will never be isolated. It will still be reachable through other paths, and this is what we have to do. And that's why this kind of infrastructure is very well protected. So if you work for a service provider like this, or if you have access to core devices, there's usually a vetting process that needs to happen to make sure that you are a person of sound mind and you know what you're doing, you have the skills that is required, and you have good intentions, because this kind of infrastructure can be used by malicious people, like terrorists. If you come, for example, let's say this is a huge device, core device in Denver, and this is a core device in LA, for example. You don't want, usually you have multiple of them. You don't have just a single one. You have like 2 or 3 of them. If you have someone that is not well intentioned, they can just come here and shut down these 3 routers. And this will create a major disruption in Denver, because I mean, you might not be the only core provider in Denver, but you might be one of the 4 or 5 main core providers. And if your services are down, of course, a huge portion of business customers will be down in, or business, even residential customers will be down. So that's why there's a whole process by the NSA, for example. This is the National Security Administration in the US. I don't know if it's the agency or administration, but they need to vet some employees. They need to do your background check and make sure that you are a good citizen or a good person in general. At this layer, we find very high-speed fiber connections between these different routers, and as I said, these are high capacity, so they're able to move many terabit per second of traffic every single day. So let's say something about these different layers that we have here. So the first one, or the core layer, is where you find high capacity routers, also called P routers, as I said, or provider routers. These are high performance routers, and they also have very high speed long haul link across large areas. They go from city to city, they go from region to region, from country to country, and many of these companies that have a huge backbone, they go from country to country, like Lumen or some of the big ones. They have those fibers laid down across the Atlantic or across the Indian Ocean, and they can access many countries around the world. So backbone and core layers are usually owned by tier 1 ISPs, and they connect all the modules and layers of service providers. By module, again, I talk about maybe the peering module or the edge module or the data center module, where they have all the data center connected, or the CDN modules, or different small sections of the ISPs are connected to the core, and the traffic can go from a region to a different region through the core. And we also have the edge layer. This one contains dedicated nodes for specific services or modules, and they also have the edge PE nodes for ISP data centers. ISPs have data centers for many reasons, just like I said, and the node or the edge node for data centers are also in this layer here, which is called the edge layer. So the next one is the aggregation layer. This one will group all the different data flows that we have coming from the access layer and from the different customers, and we'll aggregate these into high-speed links that are going to be sent to the core. And this is where we find the provide edge routers that are going to be directly connected to the customer edge routers as well. And they are located in smaller POPs. And we're going to talk about POPs in the next lessons, where we talk about the internet. This is where two or many service providers come together and exchange their connections, or it might be just the provider itself putting their router there. There are many companies that provide co-locations like Equinix, CoreSite, and so on. So they all have some kind of location where providers can put their devices in. And usually aggregation routers are found in smaller POPs compared to the provider routers that are usually in bigger POPs. And finally, we have the access layer. This is the layer that goes to the customer. This is the first layer that the customer is in touch with. So it's massively deployed and usually uses Ethernet rings. We're going to talk about metro rings and all kind of technologies that are put in place in a certain city to be able to collect all the traffic from different customers around that city and send it to the aggregation layer in order to go all the way to the core or to go to the internet gateway or all kind of things. And it also includes the last mile. The last mile is the last portion of the network that is connected directly to the customer. Not all the ISPs own the last miles going to their customers. Some of them do, but some of them don't. Usually it's owned by tier 3 service providers or local service providers. And this is where you find different kind of technologies like dark fiber, cable, DSL, or wireless technologies. So talking about the last mile, I want to give you some explanation on what happens when service providers are trying to cooperate with each other in order to deliver traffic or services for their customers. So not all the service providers are available everywhere. That's why in order to well serve your customers, you need to cooperate, or you need to talk to other service providers in order to build your circuits. Let's say, for example, you are one of the biggest tier 1 ISPs. Let's say you are Lumen, for example, and you have a customer that we're going to call customer number 1 in a certain city where you have local presence. Let's say Denver, where you even have last mile, like you have DSL connections or DSL lines going to this customer. So this customer is able to connect to your PE, and this customer has one of your, let's say, layer 2 services, maybe an E-line, for example. So you want to build an E-line for this customer leaving Denver, going to different city, let's say Jacksonville, Florida. So this customer 1 is also present in Jacksonville, Florida, and they want you to give them layer 2 access to their remote location. So you don't have local presence in Jacksonville, you don't have connections, or you don't have your DSL connections in Jacksonville, Florida. So what you're going to do is that you're going to talk to another service provider that can go all the way to the premises of your customer in Jacksonville. And this might be a small service provider, a very small service provider. Let's say it's mine. It's called Git Telecom, for example. So Git Telecom is a local service provider in Jacksonville, Florida. Git Telecom, and it can help you reach that customer. And you know, your salespeople will try to do some research and will say, hey, what connection can you have in Jacksonville? They say, hey, we have Git Telecom, for example, here locally. So they're going to talk to Git Telecom, of course. It's going to be part of the secrets. But we also need to fill this gap here. We need to find some kind of service provider that can connect to Git Telecom in Jacksonville or has a regional presence in Florida. And we can fill this by another service provider. Let's say, which one? Let's say Verizon. So Verizon has a regional presence in Florida and can also connect, even though Verizon doesn't get directly to the customer, but Verizon can at least get us to Florida where we can connect to Git Telecom. And that's what you're going to do. You're going to build an E-line. You're going to build these circuits from Denver to Jacksonville, Florida. And that circuit will have 3 components. You will have the first component that is owned by Lumen. You have the second component that will be owned by Verizon. And you have the third component that will be owned by Git Telecom. So this is how you're going to build that circuit. And let's say this customer is paying $1,500 a month to have access to this service. So you're going to share this revenue, of course. You're going to pay Verizon maybe like $400 for this section, and you're going to pay Git Telecom maybe $100, and you're going to keep the $1,100 for yourself. And at least you have a customer who, through you, can reach any other location around the country, because you are able to talk to these other providers. And as I said, you're going to send traffic or attach these connections through different POPs that you have across the countries, across the country. And these connections or the traffic from the customer can get through and go to the other side. So Git Telecom is the last mile provider. This is the last mile service provider that will help us reach the customer directly. With this kind of collaboration between service providers, you are able to reach anybody, anywhere, or to serve any kind of customers. You may even not have a presence in Denver. You can use any other last mile provider in Denver, but you just bring the customer's traffic through your core and then exit it out or speed it out in a different country or a different region of the country. All right, this is really important to know, and I hope it was helpful. So if you want to read more on this, I have a link that I'm going to leave you in the lesson where you can read a little more on the different service providers layer that I talked about here. So thank you for watching this lesson on YouTube, and if you like it, please click like on YouTube and make sure you subscribe to the channel not to miss anything that I'm putting out. And if you have any question about this, leave it in a comment or send me an email at contact@KBTrainings.com, which is right here. I'll be glad to respond. So the course is available on KBTrainings.com. That's where I go from zero to engineer. I help you learn everything that you need to know to pass the CCNA exam or to just know networking in general. Thank you so much, guys, and I'll see you in the next one. Don't forget to follow me on Facebook, Instagram, and Twitter. Take care.